Here is some data for two different materials. Perhaps one is pine and the other one oak or whatever. But all of the samples within material A are made of the same stuff. Let's say all of pine. And all blocks of B are made of the same stuff, whatever that is. The data is showing volume and its associated mass. Volume means how much space something takes up. Mass is how much matter something is made of. So we can see that here we have a small block of substance A. It only takes up a space of 10 centimeters cubed, and its mass is very light, only 1 gram. Then we have a bigger block, double as big, 20 centimeters cubed volume, and its mass is 2 grams. How are mass and volume related to one another for material A? What constants can you find within the data for material A? And the same question for material B. Pause the movie until you've answered this yourself. Mass and volume are directly proportional to one another for a certain material. If we have a block double as big as another, its mass will be double the mass of the other. 10 times 3 is 30, 1 times 3 is 3. 20 times 2 is 40, 2 times 2 is 4. 30 times 5 over 3 is 50. 3 times 5 over 3 is 5. 20 times 5 is 100. 1 times 5 is 5. 40 times 2 is 80. 2 times 2 is 4. 40 times 3 over 2 is 60. 2 times 3 over 2 is 3. And so we could go on and on and on. The point is that we have direct proportion between volume and mass. Therefore, the ratio between volume and mass is a constant for each material. You can calculate the ratio either as volume divided by mass or mass over volume. You will get a constant in both cases. For example, volume over mass for material A is always 10 centimeter cube per 1 gram. 10 centimeter cube divided by 1 gram, 10 centimeter cube per 1 gram. 20 centimeter cube divided by 2 grams is 10 centimeter cube per 1 gram, and so on. Always centimeter cube divided by mass gives you an answer of 10 centimeter cube per gram in each case for A. For B, the ratio of volume to mass is always 20 centimeter cubed per gram. 80 centimeter cubed divided by 4 grams equals 20 centimeter cubed per gram. 100 centimeter cubed per 5 grams is the same as 20 centimeter cubed per 1 gram. We can also calculate the ratio as mass per volume. For material A, our answer is always 1/10, which is 0,1 gram per centimeter cubed. 3 gram divided by 30 centimeter cubed equals 1 gram per 10 centimeter cubed. 0,1 gram per centimeter cubed. 4 grams per 40 centimeter cubed is 1 gram per 10 centimeter cubed. 0,1 gram per centimeter cubed, and so on. The mass to volume ratio for material B is also a constant, although a different constant to A's constant. B's mass to volume ratio is always 1/20th gram per centimeter cubed, which is the same thing as 0,05 grams per centimeter cubed. 1 gram per 20 centimeter cubed equals 0,05 grams per centimeter cubed. 2 gram per 40 centimeter cubed is 1/20th gram per centimeter cubed, 0,05 gram per centimeter cubed. And so you can calculate the same ratio for all of them. It's always a constant, always 0,05 grams per centimeter cubed for material B. So material A has its particular constant, 0,1 gram per centimeter cubed, and material B has its particular constant, 0,05 grams per centimeter cubed. This constant of the ratio of mass to volume has a special name in science, and it is called density. A's density is 0,1 gram per centimeter cubed. B's density is 0,05 gram per centimeter cubed.